Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker Graham Middle School. And in this video, working on that Pythagorean Theorem exit ticket. So it says to use the Pythagorean Theorem to verify if the given side lengths of a triangle form a right triangle. So we're seeing, okay, using these three side lengths, is this a right triangle? So we're asking that question. So we don't necessarily know that this is a right triangle. However, what we do know is this. We know for sure that we can always use this formula. Again, this is the Pythagorean Theorem. It states this. It says if it is a right triangle, we can use a squared plus b squared equals c squared. However, the converse, meaning this, it's almost like we're saying the opposite. So let's say if this is true, then we know it is a right triangle. So make sure you're seeing this. Again, we use the converse to verify if this is true. Make sure you also know A and B are the legs. So again, we could say these are the legs, but we know for sure this is the hypotenuse. Hypotenuse. And how do we identify that? Well, it is the largest side. So largest value, we can even say. So make sure when you're doing this, you're looking, well, I have three values here. I don't, what do? Where's my right angle? I don't know. Just relax, figure it out. Okay, my two legs are gonna be the smaller sides. So out of these three values, 42 is gonna be my largest side length. So I know this is going to be C, which is the hypotenuse. So then I can plug in my values that I do know. So I have this, I'm gonna have, all right, 24 squared plus 36 squared. We're saying, is this equal to? So I'm gonna have that question mark there. Is that equal to, let's have 42 squared. So again, make sure you're plugging in those values carefully. Again, we said 42 is going to be our hypotenuse for this possible right triangle. Again, make sure you calculate carefully. So I'm gonna say 24 squared, again, 24 squared, we have 576. We're adding it to the other side length squared. So 36 squared is 1,296. We're saying, is this equal to 42 squared, which is the hypotenuse squared? So we're saying 42 squared is 1,764. Again, add these two together. So we have 576 plus our 1,296. Those added together is 1,872, which is not equal to 1,764. So what can we say? Well, what do you think? We were saying, is this a right triangle? But it has to have that these are equal. So when you say the converse, we're saying if these side lengths, if the square of the side length is equal to the square of the hypotenuse, then it is a right triangle. However, for this case, so we could say since, always be able to justify your reasoning. So we can say since these, or we could say since the equation does not balance, so we could say the side lengths, side lengths do not form a right triangle. So again, make sure that you are seeing how that works. Again, that was to verify. So again, we're not looking for any side lengths. We're seeing, are these sum of the squares equal to the square of the hypotenuse? On the back, however, we are looking for that side length. So it reads like this. It says, use the Pythagorean theorem to find the value of x for the given right triangle. Round to the nearest 10th. So now, again, since we don't have three numbers, we have two of the values. However, how can we identify the hypotenuse? So again, make sure that's the first thing we do. So we want to identify the hypotenuse. Again, that's going to be the largest side, and it is the side opposite to the right angle. Right angle. So always get used to saying, okay, boom, right there's my right angle. Draw the arrow out to it and say, all right, well, that means my hypotenuse is 24. So this is going to be C, which is my hypotenuse. That means this, my two legs that I have for this problem are going to be 18 and x. That means that whatever value I find should be less than 24. Again, always have your Pythagorean theorem first. So I have a squared plus b squared is equal to c squared. Plug in the values that I know. Again, a and b can be moved around. It does not matter as long as you know they are legs. That's the important part. So x squared for my one leg, I have 18 squared for my other leg, and I have 24 squared for my hypotenuse. Make sure you can multiply carefully. So I have 18 squared is 324. So I have x squared plus 324 is equal to 24 squared, which is 576. So again, we're trying to see, okay, what would this value of x be? Because we're trying to get that variable by itself. We're trying to isolate the variable. Again, two-step equation, always do inverse operations. So we have 324 subtracted to both sides. On the left side, all we have remaining is x squared, and then we have equals, so let's do minus 324. So we have 252. Now, how do we get rid of this square? Well, what this is reading is this. It's saying, you know, if you have a square with area, so that would be the entire area. If you had a square with area of 252, what would one of these side lengths be? So it's just asking for a side length. So when you take a square root, that is the inverse operation of that exponent. So you take a square root of both sides. What do you get? Well, take a square root. I get 15.87. And it says to round to the nearest tenth. So when I go to do that, again, make sure you're very careful. So we're going to underline the 10th column. I'm going to circle the adjacent value. If that circle value is 5 and above, I'm going to round up. So that means I'm going to have x is about 15.9 units.